Hello students, welcome back to the online class of physics. This is your Naima Miss back with the lesson work and energy. We have learned in our previous class about what is work, what is the scientific meaning of work, what is the definition of work, which is nothing but work is equal to force into displacement, right? We have seen different examples also of how the work is being done, right? We have seen this also definition of work in science. We have seen that the positive value of what is happening when there is that when they are moving in the same direction, we are getting positive value. When they are moving in the opposite direction, when the force is moving in the opposite and the object is moving in the opposite direction, that is direction of motion is opposite, then you will have the negative value, right? We have even learned about the ideas of energy. We even learn how the energy is getting transferred and how the work is being done, right? Energy transfer and the work. We have even understood the increase and decrease in energy of an object, how this is taking place. So the next thing that is we have learned is nothing but kinetic energy. In our previous class we have learned about the kinetic energy, right? Understand the energy of moving objects. Then in today's class we will see the next energy. So let us guess which energy is that. Okay, so what we are going to do, we are just going to take the this bamboo stick, okay, and we will make a bow here like this. Then we will place an arrow made of a light stick on it with one end supported by the sting of the bow. Okay, we will just place this stick here, which will be supported with this sting bow. This is the sting of the bow, right? So what will happen, this stick will be in the support of this bow. Okay, so now what we will do, we will just stretch the sting gently and we will just release the bow. When you stretch the string like this, when you will pull it like this, what will happen, and you release it, the stick will, this arrow will come out of the bow. Now place the arrow on the bow with one end supported by the string and stretch the string, applying more force, and release the arrow. What the difference you see? When you release the arrow with a small force, you will see that it will go for some distance. When you stretch the string with full speed, full force, and you will release it, you will see that the arrow will go at a long distance. Yes. Is there any a change in the shape of the bow? No, there is no change in the shape of the bow. When the string is stretched or applied, there you can see the change in the shape of your bow, but there is no change in the shape of your arrow. Right? You may notice that in the first instance, you may notice that in the first instance, when you release the arrow, it gets separated from the bow and falls down on the ground. But in second instance, you will notice that the arrow flies with great speed into the air, isn't? So from this activity, we can conclude that the bow is normal shape and is not able to push the arrow. But when we stretch the string, it acquires energy to throw the arrow into air with a great speed. When you just keep the arrow slowly like this, when you just slowly keep arrow like this and you just push it, you will see that the arrow will slowly go and fall on the ground. But when you push the bow with such a great speed, applying some amount of great force and leave it, you'll see that the arrow will fly up into the air with a great speed. So that means the energy acquired by the bow due to change in its shape is known as its potential energy. So today we will learn about the potential energy. In our previous class we have learned about the kinetic energy. So we'll learn about the potential energy. So what is potential energy? The energy which is acquired by the bow due to the change in its shape. The energy which is acquired by the ball when we are changing the shape, that is nothing but it is potential energy. Where does the ball get this energy from? It gets energy from us when we pull it, right? In this first instance of above activity, you have gently stretched the string of the bow. You have simply just stretched the string of the bow. Thus, when the work done by the force on the bow is negligible and energy transferred to the bow due to this work is also negligible. Hence, the bow is not able to push the bow arrow, right? In second instance, you have applied more force on the string to stretch it. Thus, the work done by you on bow changes its shape, and this acquires large amount of energy. This bow is stored as potential energy. The energy which is stored by the bow when we are pulling it is nothing but it is called as potential energy in the bow, which is responsible for throwing the arrow into the air with a great speed. In our daily life, we come across many such situations. So many situations like where the work is done on the object and is stored as a potential energy in it. And it is used to do various other works. For example, when we take a car, toy car, we just fill up the winding key of the toy car, and that stores the kinetic energy like that, and when we leave it, it starts running, right? Similarly, so many, we have dancing doll. When we just wind up the key which is present back of the doll, we will just turn it like that. We just fill in the winding key and just we will leave it, it will start dancing, right? It will start dancing. So that is nothing but the potential energy we are giving to the energy, whatever force we are giving to some object, what it is doing, it is storing in it, it is storing it in the form of potential energy. The energy which it will utilize, it will not utilize immediately, it will just, when we are giving some force, it is storing it like an energy, and when we leave it, it will start, it will give it out. That is nothing but potential energy, and the force the car to move to the on the ground when released. So let us see the observing the energy in stretched rubber. What we are going to do, we are going to take a rubber band. We will take this rubber band, okay, we will hold it on the two sides. Now what we are doing, we are just holding on one side and the other side we are just leaving like this. See how slowly I'm releasing. So now I have applied some force on it. When I'm releasing it, it is getting some potential energy. So this potential energy is low, so it is not having much energy. Now what I'm doing, I'm taking it, I'm stretching more. How much amount of energy I am applying, force I am applying on this, it will store that much amount of energy. Okay, so like this. So again what I'm doing, I'm just increasing its potential, I'm increasing the force. Okay, I'm increasing the force. Now what is happening, you can see that in what speed it will come, and how much amount of potential energy it can store. See, I have stretched it this much. Now you can see, so how it came, very speed, isn't it? So this is the kind of energy which it is storing, that is nothing but it is called as potential energy. What it is called, it is called as potential energy, which is stored by the object. Absorbing the energy in an object at some height. So what we are doing, we are taking a heavy ball, we are just going to drop it on a thick bed of wet sand from the different heights, from like 25 centimeters to 1.5 centimeters meters. Okay, and we will observe the depression created by the ball. When you are throwing a heavy object into the sand, we will see what are the footprints we are getting back. Okay, what are the marks we are going to get, depressions we are going to get back. Okay, so similarly we can just note down those marks and we can see the readings. Okay, we will see the difference at if when we are throwing at from 25 centimeters, what kind of depression we are getting. When we are throwing from the 1.5 meters, how much depression we are getting. So we can see that the depression which we got from 25 centimeters is big. because more force is coming, right? More force is coming, that means the depression will be very big, heavy. We can observe that the objects also acquire energy due to the change in position. Okay, because of change in position, you can see that the objects will acquire some amount of energy. So let us consider the following example. We use a hammer to drive nails into a plank. If a hammer is placed just on the tip of the nail, it hardly moves into the plank. Simply you're taking nail and just you're trying to hit with the hammer. You just hit like this. Will the nail go into the plank or wooden plank or wall? No. You have to hit it very hard. Then only it will go, right? But if the hammer is raised to a certain height and then allowed to fall on the nail, we observe that the nail is pushed to some distance into the plank. Thus, the energy of the hammer is increased when it is raised to a certain height. This energy is due to the special position of the hammer, that is the height of the hammer. So you are raising the hammer at some more height than you are hitting, that means more energy is, more force is applied on the nail, then only the nail will go inside. So the energy possessed by an object because of its position or shape is called as potential energy. So what is potential energy? The energy possessed by an object because of its position or shape is called as its potential energy. Right, children? So potential energy, I hope it is clear now. Potential energy of an object at height or gravitational potential energy. We will learn about it. An object increases its energy when it is raised through a height. This is because of the work done on the object against the gravitation acting on it. The energy of such an object is known as gravitational potential energy. So whatever force we are applying, that is against the gravitational force, right? Whatever gravitational force, that is the force which is attracting the object towards the earth, is called as gravitational force. Now what we are doing, we are just doing opposite. We are pulling the object up, right, against the gravitational potential. So any object, it increases its energy when it is raised through a height. This is because of the work done on the object against the gravity acting on it. So this energy is called as gravitational potential energy. So the gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to that point against the gravity. So what is gravitational energy? It is nothing but when you are, see, suppose this is an object, okay, and I am trying to pull the object above the earth. Okay, so now the whatever the force we are using, whatever energy we are applying to pull this object at some height from the ground, and we are just trying to move it, right? So whatever from this point, from the point of gravity to the this point, whatever energy we are using, that is nothing but the gravitational potential energy. So let us consider an object of mass m raised to an height h from the ground. A force is required to do this, right? To pick up or to lift an object from one point to another point, we required some energy or some force. So the minimum force required to raise the mass, that is the object, is equal to the weight of the object. The object gains energy equal to the work done on it. Let the work done on the object against the gravity be W. So that is the work done is equal to, what is the formula? W is equal to force into displacement. So what we are taking, the force which we are applying is nothing but mg into, what is the displacement? It is nothing but somewhere height. Okay, some height. So that is mg into height. So which is equal to mgh. Since it is not mgh, it is not the garam masala we are using, it is mgh, that is milligrams, and this is some height. Okay, since the work done on the object is equal to the mgh, and the energy is equal to mgh units is gained by the object. So whatever this is nothing but this will be a unit now. Okay, so this is the unit of energy which is gained by the object. So this is nothing but it is the potential energy of that object. So we can write potential energy is equal to mgh. Okay children, I hope this is clear. So you have to do this examples and submit me. Okay, this will be your homework, this 7th example and 8th example. Fine children, so thanks for watching.